Hello everyone, this is Aiyshhwariya Devi, Assistant Professor, Department of CSE, Dr. MGR Educational and Research Institute. Today I am going to brief on the subject data structures in an easier way. So, the subtopics to be covered today, I'll brief that. One is definition of data structure, application of data structure, types of data structure, operations of data structure, what are the types of linked list. We are going to discuss next stack, queue, trees, tree traversals, sorting, types of sorting, and finally the applications. So these are the topics today I am going to brief. So first one is definition of data structure. What do you mean by data? First, data is a collection of informations. What do you mean by data structure? It's a way of organizing, storing and retrieving the data and their relationship with each other. So collection of information should be arranged in an organized way. That is a data structure. These are the examples of arrays, records, queue, stack, linked list, tree, graph. Everything is an example of a data structure. So next, where are the areas we are using applications of data structures? First one is operating system, compiler design, database management system, expert system, network analysis. These are the vast areas we are using the data structure. What are the types of data structure? The data structure is classified into two types. First one is primitive data structure and the second one is non-primitive data structure. Primitive means it which will be operated directly on the machine instructions. That is primitive data structures. The example of primitive data structure will comes under integer, character, float. We can't change that value. It is fixed or default. The non-primitive data structures are changed by the humans. So that is classified as homogeneous and another one is heterogeneous. Homogeneous is a linear data structure and heterogeneous is a non-linear data structure. So this non-linear data structure was what tree, graphs, etc. And homogeneous linear data structure means linear means order wise. So it is comes under linked list. So linear data structure which contains the linear, that is the orderly arrangement of an elements in a memory. That is the linear data structure. And the example of linear data structure is arrays and linked list. Non-linear data structure, a data structure which represents hierarchical arrangements. So what are the hierarchical arrangements means? It will be example of trees, graphs, everything comes under the non-linear data structure. So what are the advantages of data structure? Next we are going to see the advantages. So first one is it is easy to debug small routines than larger ones. That is the first advantage. Second one is it is easier for several people to work on modular program. What do you mean by modular programming? Means a large program or project is subdivided into smaller tasks and it is given to everyone. So that is the modular programming. A modular program places certain dependencies in only one routine, making the changes easier. So using modular programming, data structures can make easier. These are the advantages. So next, what are the basic operations of data structure? First one is traversing, searching operation, inserting operation, and deleting operation. These are the four basic operations we are using in data structures. Next, what do you mean by linear data structure? I already told linear data structure means linked list, stack, queue, if everything is a linear data structure, and non-linear data structure means tree, graph, and all comes under the non-linear data structure. Linear data structure, it's a series of nodes. So here A1, A2, A3 up to AN will be the element name. So A1 represent the first element and AN is the last element. So this n is your size of the element. So 1 to 20 elements is there means. So A1 is your first element, A20 is the last element, 20 is your size of the list. Okay. The next is types of linked list. There are three types of linked list. First one is single linked list, doubly linked list and circularly linked list. What are the operations we performed on linked list? Same insertion operation, deletion operation, finding the last element, finding previous element and finally deleting the list, whole list. These are the main operations we performed on linked list. Next, what do you mean by stack ADT? The stack will be abbreviated as LIFO. That is, LIFO is last in, first out order. The last inserted element will be deleted first. That is a common thing. A stack is a linear data structure which follows LIFO, last in, first out manner, where insertion and deletion can be performed only at one position. That is the top position. Okay. So what are the operations we perform? First one is insertion, that is push operation, deletion, that is pop operation, and current element is your top element. Okay, these are the three operations we performed on the stack ADT. So push is meant for inserting an element, pop is meant for deleting a particular element, and top is your current element. There are two exceptional conditions we used in stack. One is overflow and another one is underflow. What do you mean by overflow? Means we are attempt to insert an element when the stack is full. Already the stack is full. A box container full of chocolate boxes, the box will occupies only 20 chocolates. If you are going to put another 10 or 20 chocolates, means already it is full. So that is called as overflow. Underflow, in that box of chocolate is no chocolate is there in the box. If you want to take one chocolate from that box, that is underflow. That is an example I am telling. At underflow means attempt to delete an element when the stack is empty. Already it is empty. How you will take or delete? So that is underflow operations. These are the two exceptional conditions. One is overflow and another one is underflow. That is an example here. There's a tank. If you want to insert some other water or something, already the tank is full, means we can't able to insert any element. Overflow will occur. Okay. Next one is QADT. Q, the abbreviation is first in, first out manner. FIFO, Q will be. It's also a linear data structure which follows first in, first out principle. The example in real life example is queue. Everything is queue, right? Queue, ticket, counter, reservation of anything, everything is comes under the queue. What are the operations of queue? Means NQ and DQ. There in stack we see the push and pop operations. In queue we will see NQ. NQ is mean for inserting an element in the queue, and DQ is mean for deleting a particular element in the queue, that is DQ. These are the two operations. The real life example. What are the applications for queue? Cashier in real life, booking tickets or booking for bookstore, everything in the real life example of queue. These are the real life examples. So stack is last in, first out manner, and queue is first in, first out manner. What are the applications we are using in queue? Priority queue is the first application. Simulation is the second application. For mathematics, we are using the queue techniques, that is a queuing theory, and finally computer networks. These are the applications, some of the applications of queue. Next, we move on to the tree concept, nonlinear data structure. First one is tree. Tree is a collection of arrangement of elements in a nonlinear way. So there are two types of tree. One is binary tree and binary search tree. Binary tree. What do you mean by binary? Binary means two. Already we know that a binary tree is a tree in which no node can have more than two children. That is binary tree. The difference between binary tree and binary search tree is, in binary search tree, the left element should be smaller than the root element and the right element should be always larger than the root element. For example, the root element is 10. Okay. So if you want to insert an 20 in that element, means you have to insert in the right hand side in the binary search tree. And if you want to insert 5 or 2, means you have to insert in the left hand side. That's what I am saying, that the element in the left hand side is smaller than the root element and the element in the right hand side is larger than the root element. That is binary search tree condition. In binary tree there is no condition, only that will be two children and not more than two children. That is a condition. It will be one or two children. That is the condition. So this is a simple example for A, B, C. I am taking as A as a root node and B and C are children of that A. Okay, child nodes. And this for B, D and E are the children's, and for C, F and G are the children's. There is a simple binary tree example. Next one is tree traversal. Tree traversal means traveling each node at least once. This is a simple definition. Traveling each node at least once. That is a tree traversal. Okay. There are three types of tree traversal. One is pre-order traversal, post-order traversal, and in-order traversal. A simple click is in pre-order traversal, the root element will be present in the first. In in-order traversal, the root element will be present in between left and right element. In post-order traversal, the root element will be present at the last. That is a simple click, a trick for the tree traversal techniques. Pre-order, in-order and post-order. Pre-order, root element will be first element. In-order, root element will be the middle element, and post-order, root element will be the last element. Next one is sorting techniques. What do you mean by sorting? We already know that sorting is the arrangement of elements in an ascending or descending order. That is the sorting. Okay. So for example, telephone directory, dictionary, everything comes under sorting only. For example, in dictionary A to Z, the alphabet will be in a sorted order. Okay. So there are many types of sorting. The types of sorting can be defined as quick sorting, insertion, merge sorting, bubble sorting, and heap sorting. Today I am going to discuss one of the sorting, merge sorting. This merge sorting is a very important technique which works under the divide and conquer technique. What do you mean by divide and conquer technique? Means it already works under the modularity concept. The large program, a large task is subdivided into several modules, and finally we will arrange that element in an ascending or descending order. That is the merge sorting principle, simple principle. Okay. To understand this merge sort, we have to take an unsorted array. In the example I will tell. So this is one merge sorting example, 6, 5, 12, 10, 9, 1. This is an unsorted array. We have to orderly arrange it in, and final answer will be your ascending order of that particular array element. So first we have to divide an element. Totally 6 elements are there. We have to divide that element as 3 and 3. So 6, 5 and 12 in the left hand side, 10, 9 and 1 in the right hand side. So again these three elements are subdivided into modules. So sixth element is in the left hand side and 5 and 12 will be in the right hand side. Here the same procedure, 10 is in the left hand side and 9 and 1 in the right hand side. Again we can't able to divide this left hand side element, so we'll put as 6. So this 5 and 12 right hand side is subdivided into 5 is one element, 12 one element. Same 10 we can't change anything in the left hand side. So 9 is subdivided into a separate element and 1 is subdivided into a separate element. For example, first one is 6. Already we put that. For 5 and 12, already it is in the ascending order. So we arrange the 5. Next element is 12. The 10 is in the order wise element. So we will put the 10 as it is. Then 9 and 1. Compared to 9 and 1, 1 is the smallest element and 9 is the largest element. So we will arrange it in the ascending order. So finally, in compared with, again we are merging the particular element. First subdividing the task and finally we are merging the task. That is called as merge sorting. Finally we have to arrange the elements in the ascending order. So in 6, 5 and 12, which is the smallest element? 5 is the smallest element. The next smallest element will be 6. The finally 12. So in the left hand side it is arranged. So in the right hand side, if we see that 1 is the smallest element, the next smallest element is 9, the next smallest element will be the last element in the 10. So it is merged into a subtopic. So finally we have to arrange in a single array. Okay, so single array means which is the smallest element from this left hand side and right hand side. We have to see that. So first 1 is the smallest element. Next smallest element will be 5. Next smallest element 6, 9, 10 and 12. So this is the merge sorting. It works under modular programming. So we have to divide the elements into each column and finally we have to merge that particular thing in ascending order. That is the merge sorting. It is a very important and easy technique. So next, what are the companies use data structure as application? So now companies like Amazon, Microsoft, Google focuses on data structures and algorithms. Mostly all product based companies place so much importance on this data structure algorithms. So nowadays for each and every concept in the backside, data structures is very much useful. So it's a simple technique. Using this algorithm we can do anything. So hope you all understood this session. Thank you very much.